Hey guys, welcome to ANS Solver. Today we'll be doing the past paper examples of all the identities. Okay, from the last 5 videos, we have been doing only the concept. So now, as promised, we'll be doing the past paper examples. Okay, so that you know how to apply the concept which you learned. Okay, so now let's start with the first past paper example. Okay, which is basically from 2020, Feb March paper 22. Okay, so we need to solve the equation 2 sine theta plus 30 degrees plus 5 cos theta, which is equal to 2 sine theta. Okay, where theta lies in between 0 degrees and 90 degrees. Correct? This is what I simply have. So here, what you need to do is, first you need to identify. Okay, as you can see here, I have the sine compound angle formula, correct, which can be used. So I can write this as 2 multiplied by, I know that the sine compound angle formula, okay, is basically sine A plus B is equal to sine A, correct, plus cos B plus cos A sine B, correct. This is what the compound angle formula is. So here my A is theta and my B is 30 degrees. So I can write this as sine theta cos 30 degrees plus cos theta sine 30 degrees. Correct? This is what I simply get, plus 5 cos theta equals to 2 sine theta. Correct? So now, what is cos 30? First, you can write this as 2 into sine theta. I know cos 30 degrees. So what you can do is, on your calci, correct, in the degree mode, how do you go to the degree mode? You can simply click on shift, correct, you can click on shift and then you can click on mode, and as you can see, the domain here is in degrees, correct. So click on 3, correct. So when you do that, you are in the degree mode. So now when you do cos 30 on your calci, correct, you get your answer as root 3 by 2, correct, plus you do cos theta, correct, then again in the degree mode you do sine 30, so you basically get half, correct, which is plus 5 cos theta equals to 2 sine theta, correct. So now when I take this 2 inside the bracket, I basically get root 3 sine theta, correct, plus cos theta plus 5 cos theta, which is equal to 2 sine theta, correct. This is what I basically get. So I can keep the cos theta and the sine theta together. So I can write this as cos theta plus 5 cos theta, which is equal to 2 sine theta, correct, minus root 3 sine theta. So now I can simply write this as 6 cos theta, which is equal to, here I can do 2 minus root 3 sine theta, correct. This is what I simply get here. So now what I can do is, I can rearrange this as 6 over, I'll just write this, I'll leave a line and write so that you're clear, 6 over 2 minus root 3, which is equal to sine theta divided by cos theta, correct. So now sine theta over cos theta is tan theta, correct. So the tan theta is basically equal to 6 over 2 minus root 3, correct. Now you do theta, which is equal to the tan inverse, okay, of 6 over 2 minus root 3, correct. So in the degree mode, make sure you're on the degree mode because that's the most important thing, correct. When you simply solve this, you get your answer basically as your theta as 87.4 degrees, correct, which is basically your final answer, correct. and it's in degrees, correct, because the domain here you have is in degrees. Okay, so the step was first, identify which identity to use. Here this was a sine compound angle formula. Okay, remember the identity, apply the identity, then you will basically get algebra, and then you just need to solve directly, correct? And here another thing, we'll use ASTC. Okay, and we know we'll only get one answer here, which is 87.4, correct, because the domain which I have is basically from 0 degrees to 90 degrees. Okay, so basically I'll only get one answer, which is in the first quadrant, correct, because 0 degrees to 90 degrees is in the first quadrant, correct? So yeah, now we can go to the next past paper example, which is basically from 2020 October November paper 22. So here I need to solve the equation 7 cot theta, which is equal to 3 cosec theta, okay, for 0 degrees to 90 degrees, correct? So now I can write this as 7 multiplied by, I can write cot theta as 1 over tan theta, which is equal to 3 multiplied by cosec theta as 1 over sine theta. So I can write this as 7 multiplied by 1 over tan theta is basically cos theta over sine theta, which is equal to 3 over sine theta, correct? This is what I can do. So now as you can see, I can cancel sine theta on both sides, correct? So I simply get 7 cos theta, which is equal to 3. So I get my cos theta as 3 over 7, correct? Now I need the cos to be positive, correct? So you remember ASTC. So I have ASTC here. I need cos theta to be positive, which is in the first quadrant and the last quadrant. But here my domain is from 0 to 90 degrees and the last quadrant is exceeding the 90. So I'll only get a first quadrant value. So I do theta, which is equal to cos inverse of 3 over 7, correct? So I solve this on the calci, correct? And make sure you're on the degree mode because that's your domain in the degree mode. So when you do the cos inverse, okay, of 3 over 7, okay, you basically get your answer as 64.6 degrees. And this will be your only answer, as only the first quadrant, okay, is my domain, correct? That's why we eliminated the fourth quadrant, because it's exceeding 90 degrees, correct? So this is the only answer which I have. Now I can go here to the second part, okay, the third past paper example, sorry. This is from 2021 Feb March paper 22. Okay, so I basically need to solve the equation sec square cot theta, which is equal to 8, okay, between 0 to pi. As you can see, there's radian here. Okay, the first thing you can do is convert it into the radian mode. So click on shift. When you click on shift, click on mode, correct? When you click on mode, click simply on 4 for radian, correct? So when you do that, okay, you get the radian mode. So now I can start applying my identities. So I have sec square theta cot theta, which is equal to 8, correct? This is what I have. So now I can write my sec square theta as 1 divided by cos square theta multiplied by, I can write cot theta, which is 1 over tan theta, as cos theta over sine theta, which is equal to 8. Now what I can simply do is I can cancel 1 cos theta here and I can cancel this square here. So I simply get 1 divided by cos theta sine theta, which is equal to 8, correct? So I simply get my cos theta and my sin theta, which is equal to 1 over 8. Correct? This is what I simply get. So now what you need to know is, you need to know you need to remember actually the sine double angle formula. You know, the double angle formula of sine is basically sine 2 theta, which is equal to 2 sine theta, correct, cos theta. This is what you basically get. So now, as you can see here, I have a cos theta sine theta here, and I have a sine theta cos theta here. So I can simply write this as sine theta cos theta, which is equal to sine 2 theta over 2. Correct? So I can simply write this as sine 2 theta over 2, basic substitution, which is equal to 1 over 8. So I get my sine 2 theta basically as 2 over 8. So I get my sine 2 theta as 1 over 4. Correct? This is what I simply get. Understood the steps till here? You need to be, you need to think like this. When you have a cos theta, sine theta, you need to see how, you can use this formula and write everything in terms of sine theta, cos theta. Correct? This level of thinking, okay? You need to, start thinking like this so that you get your answer correct. So yeah, now let's calculate this. So I have sine 2 theta equals to 1 over 4. I need sine to be positive. Correct? Where is sine positive? I have my ASTC. Sine is positive in the first quadrant and sine is positive in the second quadrant. For the first quadrant, let's say I'll have x here, I'll have x here, so this will be 180, or in this case it will be pi minus x. So first, how do I calculate x? We do 2 theta, which is equal to, make sure you're in the radian mode. First do the sine inverse of 1 over 4. When you do that, you get basically your x, which is in the first quadrant as 0.25268, comma, now because even the second quadrant is involved, you do pi minus 0.25268, which gives you 2.8889. But now, these are not your final answers. You basically need your theta. So that's basically 0.25268 divided by 2. Correct? Where you simply get 0.126. Correct? Comma, when you do 2.8889, correct, divided by 2, you get your answer basically as 1.44. Correct? This is what you get. So theta has both of these values, correct, as your answer. Correct? And as you can see, both lie in the domain from 0 to pi. So we don't need to eliminate any value. Correct? So both of these are my final answers. Correct? So this sum was really good. You have to use the sine double angle formula in a very different way. Correct? So you need to, start thinking like this, which will only happen via practice. Correct? Now, I have another example here. So this was basically from 2018, May-June, paper 32. Okay? So this is basically the second question here. So showing all necessary working, solve the equation cot theta plus 45 degrees, which is equal to 2. And the domain I have is 0 degrees to 180 degrees. So the first step, simple. Click on shift. When you click on shift, click on mode and then click on 3. Correct? When you do that, you come basically in the degree mode. So now I have my equation. Correct? So I'll write my equation down first. I have cot theta plus cot theta plus 45 degrees, which is equal to 2. So cot theta is basically 1 divided by tan theta, correct? Plus, I can write cot theta plus 45 degrees as 1 over tan theta plus 45 degrees, which is equal to 2. So I can simply write this as 1 over tan theta plus 1 divided by, I can use the tan compound angle formula here in the denominator. So you need to know that tan A plus B is basically tan A, correct? Plus tan B divided by 1 minus tan A tan B, correct? So I can simply write this as tan theta plus tan 45 degrees, correct, which is divided by 1 minus tan theta tan 45 degrees, correct, which is equal to 2. Now I can simply write this as 1 over tan theta, correct, plus I have 1 divided by tan theta plus, I know tan 45 degrees is basically 1. It is divided by 1 minus tan theta, which is equal to 2. So I can write this as 1 over tan theta plus, I know I can get this portion to the numerator here, correct? So I can write this as 1 minus tan theta divided by 1 plus tan theta, which is equal to 2. So now I can simply write this as 1 multiplied by 1 plus tan theta plus, I can do tan theta multiplied by 1 minus tan theta, correct, which is simply divided by, correct, I can do tan theta multiplied by 1 plus tan theta, which is equal to 2. So I can write this as 1 plus tan theta plus tan theta, when I take this tan theta here inside the bracket, minus tan square theta, which is simply divided by, when I take this tan theta inside the bracket, I get tan theta plus tan square theta, which is basically equal to 2. Okay, so I can write this as 1 plus, I can do tan theta plus tan theta, which is 2 tan theta minus tan square theta, which is equal to 2 into tan square theta plus tan theta, correct? This is what I basically get. So I can simply write this as 1 plus 2 tan theta minus tan square theta, which is equal to 2 tan square theta plus 2 tan theta. Now I can get everything to one side and I can write this as 2 tan square theta, correct, plus tan square theta plus 2 tan theta minus 2 tan theta, correct, plus, or actually minus 1, because you're taking 1 to the other side. So I get minus 1 is equal to 0, correct? So I basically get 2 tan square theta plus tan square theta, which is 3 tan square theta. 2 tan theta will get cancelled, so I'll get minus 1, which is equal to 0. So I simply get 3 tan square theta, which is equal to 1. So I get my tan square theta as 1 over 3, correct? So now, because tan square theta is basically tan theta the whole square, when I take square to the other side, I get the root, okay, of 1 over 3. And whenever there's a square root, I write plus and minus. So I simply have tan theta, which is equal to the root of 1 over 3, and I have tan theta, which is equal to minus the root of 1 over 3. Correct? So now basically these are two possibilities. Okay, so we go one by one. So first, here I need tan theta to be positive. So I'll make my ASTC curve. Correct? We'll see the domain again just to be sure. Okay, it's from 0 degrees to 180 degrees. Correct? So I have A, S, T and C. Correct? I have 0 here, 180 here. I need tan theta to be positive, which is positive in the first quadrant and the third quadrant. But I know the third quadrant here will exceed 180 degrees. Obviously, that means the only possible answer will be the first quadrant value. So for that, I do theta, which is equal to the tan inverse, okay, of root of 1 over 3. Correct? So when I do that, okay, in the degree mode, I get my theta basically as 30 degrees. So this is one value for theta. And here, now the second possibility, here I need tan theta to be negative. So basically, I have my ASTC curve here. Correct? Where is tan theta negative? I have 0 here and 180 degrees here. Tan theta is negative in the second quadrant, correct? And the fourth quadrant. But now the fourth quadrant is exceeding 180 degrees. So I only have the second quadrant, which is given by 180 minus theta, correct? Now we need the theta. Theta is basically the value in the first quadrant. And to calculate theta, we do normally the tan inverse of always the positive. I know there's a negative here, but always the positive root of 1 over 3. Okay, you never do tan inverse of negative. Okay, you need to remember this. You never do the tan inverse of any negative number in the first quadrant. You need to remember this. I'm noting this down. Very important note. This is always positive. Correct? This is always positive as it's in the first, okay, quadrant. Okay, this is a really important thing which you need to know. Okay, so now when I do the tan inverse of root of 1 over 3, I basically get 30 degrees. Now basically I need 180 minus 30 degrees to get my answer, which is simply 150 degrees. So basically 30 degrees here and 150 degrees are my final answer. Correct? So with this, we come to the end of the past paper examples. Okay, but the thing with trigonometry is, okay, it's very concept based. It has a lot of formulas. Okay, you need to practice a lot of questions. Okay, you need to practice a lot of questions to, to get a proper grip on especially the identities. Okay, so there's only one small concept left, okay, which will be the next video, the last video, which is the R sine alpha plus beta form. Okay, it's a very simple concept. So after that, please, properly solve all the topic wise questions. And if you get stuck, we provide video and pictorial solutions, so you can have a look and you can be doubt free totally and you can get a good grip on this chapter. Correct? So see you in the next video. Thank you for watching.